Hello, everybody.
Hello.
So this is going to be on. So who has been to my past sessions on logon duration or anything in the past? Okay, so some guys are familiar with the stuff that we did before. For the ones who are not, let me just tell you where the data is coming from and what exactly are we showing. So as you guys know, Control App, we gather a lot of data from our customers around the world, and basically what we do with it is we use the data that we gather from our different customers for all sorts of things, all very exciting, and we have more exciting plans for using the data, but my favorite use of this data so far has been sort of publishing the results for the community and getting the reaction of what people feel like about the results when they look at them in the global context. So for example, we monitored logon duration. We did a study on logon duration on 250 million logons from the entire world. We published it. There is a paper out there. If you look for slow logons and Control App, you will see that there's a research paper that you can read about logon duration. And it was really nice how over the time that we've been spending on researching logon duration to hear the reactions from the field. So consultants and experts and people from Citrix have been talking to us and saying stuff like, we've been looking at user experience for 10, 12, 15 years, but we never had real global data. Because if somebody does have the data, and I believe there are a few companies out there who do have the data about what user experience looks like around the world, somehow nobody wants to publish it, right? Some people just tend to hold it to themselves, and I don't know what they do with it in the dark. But to us, the best use for the data is to expose it. And we were surprised by how many productive responses did we get and how many interesting projects spun up from that. So what I'm going to show you today is a result of research on application load time. Okay, of how long does it take basically to open applications, right? Which is sort of similar to logon duration if you think about it. So with logon duration, what we researched was how long does it take for you to log on, right? So as soon as you type your username and your password, you hit enter, and how long does it take to get an actual desktop or to see your application. Now, one common question that gets asked around this is why should we even care, right? So why is it important to talk about logon duration or application load time? Why should we care how long does it take people to open their computer? It sounds like a trivial thing. Sometimes, yeah, if somebody comes to work and they log on and they hit enter, if it takes a little bit longer, so yeah, they can maybe look at their phone, they can maybe look out the window, they can say hello to their colleagues, they can have a beer. I don't know, there's a lot of things you can do while your desktop is loading. So one common question is, why the hell should we care about this? And I have a small story for you of why should we care about logon duration. And the story comes from the delivery room in the hospital, where my daughter, my first daughter, 2 months ago, she was born in Jerusalem. So
let's have a beer on that.
Yeah, sure. So by the way, same rules as yesterday's session. So any question is encouraged and incentivized, in addition to the beers that Andreas is supplying. So
one is for you, man.
You open for a barter?
Thank you.
So, cheers, guys.
Cheers.
So we were in the delivery room, and as you know, there is some procedures today, some medical procedures require the computer, and the doctor arrives and he needs to administer the the anesthesia, right? So the doctor arrives and he needs to make a small checkbox on the computer for the procedure to continue. That's the procedure.
Continue.
Yes. So the guy logs on. You know, he puts his username and his password, and as soon as he hits enter, and I'm there in the delivery room, I'm saying, oh, not logon duration again, right? Not now. And I see the prompt. It was Windows 7, right? And I see the waiting prompt for for the machine, and as you can imagine, this is a point where every second is painful, right? So it took about
Also to you.
a minute. Well, I'm the least suffering person in the room, maybe with the exception of the doctor, but really, it started loading, and I'm counting. I have this habit now with researching log-on duration and application load time. I have a background process in my head. Every time I start something that requires a wait, there's just a timer going on, so I'm counting the seconds. It's just automatic. I can't control it anymore. So, so this guy hits enter, and it takes 10 seconds, 20 seconds, 40 seconds, a minute and a half. Try to pinch yourself or make something other that's mildly painful and see what a minute and a half feels like. So it took about a minute and a half. And this to me was, and it sounds like I'm making this up because it's so directly relevant for this research that I did, and it just got me in that moment that to me it was like a perfect illustration of why log-on duration or application load time or any part of user experience can be not only the user's experience as the computer user itself, but all the people who are affected by it. And think about it, who's affected by user experience of knowledge workers? Customers, the public that comes to a government agency and they need to do some bureaucratic stuff, or the insurance company where you need someone to react to your claim. You call support, somebody is doing something on the computer, they're waiting for something to load. But obviously the main industry which was very interested in this was healthcare. Because in healthcare people like for stuff to work. And fortunately so, right? So people like for stuff to work and they like it to work fast. So there was a lot of good reactions on our research from the healthcare industry. So what I'd like to sort of define here is user experience, some sort of user experience metrics like this that says what is an optimal user experience. And this is really simplistic, right? But the optimal user experience is that you log on and you start working. You're not supposed to be dealing with any delays or noticing anything that makes you wait, right? That's the optimal, that's the best scenario. The acceptable scenario, what usually happens everywhere, or most places, is that you log on, you wait for a little bit, and then you carry on working. And when I say a little bit, that can be like 10 to 20 seconds, 5 to 10 seconds, that depends. But still, this is I guess this is our familiar experience, right? We log on, we wait for a little bit, or we ask for an application, we wait for the published application to load, you know, all this stuff. So some things happen, and until like 10, 15 seconds you get what you need. So that's the common flow. And there is the problematic or horrible flow, which happens more often than you would think, which goes, you log on, you wait, especially if you wait more than 30 seconds. And again, those are just rough numbers, but we all know the experience. When you wait for more than 30 seconds, you start thinking, maybe I should do something else now. Even if you do it every day, right? You're thinking, maybe I should do something else. Maybe I have another thing. Maybe I have like a nice movie I can watch in the meantime on the side, or check my phone, or go read a book, or maybe I need to go to the bathroom. But you start thinking about things that you would not normally think if the user experience would just flow, right? So let's keep this distinction in mind and say that we would all prefer things to work really fast, right? And if we need a break, we'll take a break, probably. But if the breaks are forced on me by stuff that is slow and horrible, then your concentration breaks. You might, and let's think about the horrible user experience side, right? So what are the things that you are likely to do when things are slow? You either switch to something else. You either get pissed off and try to click the application again. Think of an end user, typical end user, right? Something is not opening, they'll click it again. What happens if they click it again? Everything becomes worse, not better. You know, they're just multiplying whatever the system needs to do. They will try calling support. They will unplug the computer, they'll replug it again. They'll take it out on the nurse. Think of a doctor-patient scenario, right? So all the different stuff that can happen when things are slow, and let's just say slow more than 30 seconds, right? So all this stuff that happens, I think it's hurting productivity. And some healthcare organizations are really nice this way because they have a number they can assign, and it's sometimes it's 2 cents per second. That's what I heard, 2 cents per second, or all sorts of 2 cents per minute. That was. So for a doctor, there's just a dollar amount they assign to the wasted time, or of each doctor, and the more expensive the employee becomes, obviously it becomes more easy to spot. So let's see what we measured exactly, and then I'll show you the actual results what we had. But questions so far?
Quick question: will you later publish the results of the research?
Sorry?
To everyone?
Yeah. So it's coming out as a research paper, just like log on duration.
PDF?
We've got full PDF of everything. What you see here is pretty much the first time I'm showing the results before the research is even out. And I have my hidden agenda here. So my hidden agenda is actually to show you the results and then talk about what can be done. And in this area, I think I can maybe show you all sorts of stuff that you didn't think about in terms of the numbers, but I'm counting on this room to bring us ideas on what can be done with this horrible situation with user experience, right? So there's a lot of expertise and a lot of good minds in this room, and of course this is how we're going to use it. So it's a very good question, Natan, by the way.
Thank you, sir.
So what did we actually measure? So to us, in-control log on duration is defined as the time between the start of the process, right? So it doesn't really matter if it's a published application or a local application that you're running, but when Windows processes started, right? That's pretty early. That's usually pretty early in the lifetime of an application. Sometimes some stuff, obviously published applications, there's the brokering period that's happening before the actual process is started, but that's the way we're defining it here, right? So when the Windows process is started, the application starts to load, then it loads whatever it needs to load in terms of the document. For example, here you can see, I don't know if you can see it, but
It's already 2 p.m.
yeah, so if it's opening a huge file, so you see this prompt on Excel that it's opening the document. And the end of the process is when the document is ready. Now, this is where it becomes fluffy. What do I mean by the document is ready? So what we try to do is approximate the time where the user doesn't need to wait anymore. So let's take a case of an Excel document, right? You open a spreadsheet. As a user, how would you assess the time that it's done loading? How do you know it's done loading?
I can start typing.
Yeah, exactly. You put your mouse in some cell and start typing. So that's when the UI becomes responsive. Up until that time, it may be still loading. It may be showing the UI, the window itself, but it's still not accessible to you. So this world of trying to hook onto those processes and to know what exactly is going on system-wise is a nightmare. Monitoring-wise, this is a nightmare. There's all sorts of software in the world that does this, okay? All sorts of programs that go and try to analyze the activity of the application, and I'm very sympathetic to everyone who ever tried, because it's such a hard and horrible challenge. Why is it such a hard and horrible challenge? Think of this Excel document, right? So you open this Excel document. Would you think that an Office or a Windows application would tell you, hey, I'm ready, I'm done loading? Well, we'd probably expect it, but it doesn't. Even if it does, it's not the same. So some applications do have some sort of indication, hey, UI is ready. If you look at it, what it actually corresponds to on your clock and with the user experience, it doesn't tell the true story. And even if it does tell the true story, it's not standard. This was written in C++, this was in .NET, this is a WinForm, this is a web application. There's no standard event in the OS, or reliable event that says, I'm done loading. This is the time to stop the counter, right? Yes, Andres.
What about the idea of pressing the good old Alt and button to open up the menu, like File, things like that? Maybe you can press it by milliseconds all the time, Alt, and once it's going to be loaded everything, the file menu.
Yeah, but the user switches between
So you're talking about like if we were to build a perfect measuring
That's
solution,
an idea, yeah.
I would probably do something like that, right? Or hook onto some functions, okay? Just know which functions are going up and down when the applications are loading. The problem is nothing is standard, right? The problem with doing something like that, like injecting some sort of input, is you're interfering with what you're loading. And to me, I asked for a graphics designer to make some pictures for the new article. So the picture, which is not yet here, but they're working on it. I was thinking about a picture of like a cyclist or a sportsman running with all sorts of measurement instruments attached to him, right? Because it's so, this is how hard it is to actually measure what is going on with the applications. If you want to measure it really well, then you're going to interfere with whatever's going on. You're going to load filter drivers, you're going to load additional, and that's one thing that we really don't want to do, right? So we don't want to make it even more horrible by trying to monitor it. I don't want to diss or say any unnecessary compliments to other UX monitoring solutions. There are quite a few, and quite a few good ones. All of them are dangerous in terms of compatibility. You plug in a good deep monitoring solution for user experience, most of the time you're going to create issues, right? So it's good for a lab. I wouldn't put it on mass production scale without really extensive testing. So the challenge here is trying to see how long does it take to actually load an app without affecting it, or with minimum effect.
Second idea.
Yeah.
You said there's no standard.
Yeah.
There is only one standard, meaning you can close it. You can put the X. So isn't an application loaded fully when you can close it?
Sometimes, actually, with the newer versions of Office, you can actually cancel the uploading on the splash screen. But
That's
again,
an idea.
no, it's all perfectly. So to me, all of those ideas are like they're in categories, and the most promising category is always doing something active. So interfering in it in some sort of active way. But to me,
You
there's
need a shot, Eugene.
definitely.
Two. Maybe two. No, just one.
So
This is glass.
okay, so how did we go about monitoring when is the application ended loading? Okay, we're starting to use, we started to play with all sorts of heuristics. So like simple rules that we can cut corners with. Just do something simple that will be working or reliable in most of the cases, and maybe we missed here and there, but we want to look for something that's fairly reliable and minimally intrusive in terms of monitoring the system. So what we came up with was an interesting model which just takes into account the activity of the process. So say you're starting Excel, it's doing something. Let's just look at the performance counters and see where they just calm down. Okay, so when you're opening a process and it's loading an application, and again, this is probability, I'm not talking certainty, right? But probability is when it's done being busy, loading files, DLLs, I don't know, reading from disk, loading stuff to memory. When it's done, the performance counters will go down. So let's look for that. So basically, okay, just in a basic high-level description, that's what we're doing. We're looking at performance counters and waiting for them to calm down. And once they calm down sufficiently, okay, we're using some math to calculate when is that happening. And the good news are that when we test and correlate this with an actual stopwatch, right, it's good results. It's pretty reliable, right? It's not 100%, but it's pretty reliable. And the even better news is that it's not intrusive, because I'm looking at performance counters which are there anyhow, right? So we monitor the application load time, we get fairly good results, and we're not hurting the system too much. Okay, so far so good. Yes?
What if you have a nervous user, as you mentioned before, who clicks 10 times the application start, it will not calm down for the next 10 minutes?
Yes, but it's probably, I mean, in terms of monitoring, the result is probably faithful, because you have multiple processes, right? You have now spawned multiple processes, and they're affecting each other. They're affecting the same resources, so all of them are going to be slow. Chances are, yeah,
You mentioned
definitely.
each and every-
Yeah, it's per process. It's per individual process, so every process gets its own application load time. By the way, the feature itself in the product is opt-in. So by default, we don't measure for any application. We just measure for a set of Office applications, and you can set it manually for any type of application. So some of our customers actually monitoring other applications, like medical records applications, all sorts of interesting stuff. What we're showing here today is just a set of default applications. So you will see results for Microsoft Office, for Internet Explorer, and for Chrome. Just so that you have an idea about how common are those applications. So we have, this is about 280 organizations in total from different countries in the world. 60% of our customers are in the US, so in this sample it's also similar. 138 million application launches, and this is how they partition popularity-wise between the different applications. So most of the results are actually Internet Explorer results, okay, which is in itself sort of news, right? So it's Internet Explorer is really common as a published application, turns out, and not only in published application, also in virtual desktops. All of those results include both published applications and virtual desktops, right? Excel, Word, Outlook, Chrome, and PowerPoint. This is just by way of popularity, and the y-axis here is the total launches per day. So for all of our customers, Internet Explorer is getting launched about 500,000 times per day. Right? So this is just to show you the relative share of each application in the sample. Now, let's define a little bit the results. This summarizes all the results. Don't try to understand it. It's just here for beauty. There's just colors. But there's a little bit of a logic to this chart. Let me just explain it. So let's just define a few key metrics. So the average load time, this is the time that it takes to load an application on average in our organization. For example, Excel in one particular organization may take 2 seconds to load on average. For example, this particular guy here. Okay, this bubble, you see this gray bubble, I'm going to zoom out again. So this gray bubble here represents an organization which has Word launched about 300 times a day, okay? And it has an average load time of about 2 seconds. This is the axis here. I know it's maybe a little bit confusing that the 0 is on top. Yeah, 0 is on top, but there's a reason for that. Because we like Gartner, right? We want to see the magic quadrant. So the best and good stuff is on the right top, right? So that's what I wanted the chart to look like. So if your user experience is really good, then you're on the right top, right? And if you have a few application launches per day, so you're a small circle. If you have a lot of application launches per day, you have a huge circle. And the color of the circles is the type of application. So that's the code to this, and we'll break this down in a second. It will be more clear. But the idea was to sort of plot everything on this chart, and let's take a couple more examples. So this orange circle over here represents Excel with 7,000 launches per day in an organization. So see, the average load time is about 5 seconds. So it's average. You can see it's right in the middle like that. But the standard deviation, this axis here, the standard deviation is about 5 seconds too. So what that means is that it may be average. On average, it's maybe all right. Okay, this takes about 5 seconds to load, but there's a relatively high degree of variability. So when you're talking about user experience, there are two things that matter. One is the speed itself, and the other is consistency. How consistent is it? Because if it's really fast to load most of the time, but then sometimes it's horribly slow for some reason, then you have a user experience which is inconsistent, which is sometimes arguably even worse than having a consistently slow experience. Because users tend to get used to what's going on. If it consistently takes 10 seconds, they will live with it. Better not, but they tend to live with it. And if sometimes it becomes horribly slow, they will be not happy. Okay, so, and like in the case of this particular organization C, right, you see that yellow circle here, so that's 1,000 launches per day of Outlook in a specific customer, which is both slow, right? It's slow because it has more than 9 seconds average load time, and it's very inconsistent, over 6 seconds standard deviation. So this organization will probably need to work a little bit more on user experience and try to improve the output flow time. So this is the main picture. Now let's look at different specific applications. So that's what Internet Explorer looks like. Okay, Internet Explorer. First of all, the size of the bubbles means that there are organizations with significant number of launches per day, hundreds of thousands sometimes. So on average, Internet Explorer takes about 5 seconds to load. Okay, in this sample, standard deviation about 4 seconds, and this is based on 81 million launches. What does this tell us? So my idea behind plotting this results like that, and not just showing the average or the deviation, but showing you the actual bubbles here, is to see how much better can you really get, right? So if you're trying to achieve an improvement, say your organization has a 8-second average, right? How much better is it realistic for it to get, right? If you want to get to 2 seconds average, you're going to have to work hard, right? If you want to get to a 5-second average, that's around the average, so it's probably realistic, right? But in terms of the idea was to show that if you're running Internet Explorer and you're worried about the time it takes it to load, this is more or less the range where you have to play. And as you can see, you will compare it to the other charts that I see, but as you can see, it's more or less like on the diagonal like that. So that means that if you're the longer it takes to load the application, the deviation also rises. So the slower it is, the more variable it is as well, right? So, question so far? What does it mean basically that next time you open Internet Explorer, count how many seconds actually pass until you have the web page and it's ready for you? Okay, and if it's under 5 seconds, you're probably in good shape. If it's above 5 seconds, then you have a room for improvement.
But the website also has something to say about that, because my start page is a local HTML file, so that should be
great.
Really,
so,
but I will be in the tiny dot in the top.
What I tried to do here is to sort of list the common factors that affect load time. So why should it be slow or why should it be fast? So one of them, like you're saying, this is your actual content, right? What you're loading. We are taking that into account. So this is taken into account. This includes the page load time because, again, the assumption is if the page has something to load, then it will have a performance impact. And we're looking at the counters, so it's included here. So, but your homepage is definitely an important factor. If you have 1,000 users opening the browser a day, and their homepage is set to a page that's full of graphics and I don't know what, active components and external stuff and a video and I don't know what, and it happens a lot. And the internet homepage can be like horrible in terms of the amount of stuff that's loading there. And the question is, do people really need it, right? Is it really needed for every user to open and load all of this homepage? And it's definitely a factor. Now,
No, I only need one.
Oh, it's all for me.
yeah. But Rob definitely deserves one. So, add-ons for any browser, right? Add-ons on the browser, cookies, cache, the content of the actual web page being loaded. Can you think of other things that affect the login? Sorry? Bandwidth, of course. So this is something that I didn't state here because if you think about it, every application, including Office, right? If it's loading something from the network, then the bandwidth is going to be a common factor. So we're going to talk about common factors in the end, right? Trying to see, because something like bandwidth, or like again CPU or I/O or RAM or any resource, any computing resource, basically, this affects everything, not only the browsers, right? But specifically for browsers, I would definitely look at those things. If you can disable any add-ons, right? And I'm not I don't have ready-made answers for you here. Change this registry key; it will make anything faster. But it's definitely the areas to look around, right?
How do you call it? The target websites down. That's what running slow. So if you're on that web page and it's could be running really slow, but nobody uses something like that. to see how long time to resolve.
So you're talking about the resolution. So there's the resolution
the
phase.
actual website you're visiting.
Yeah.
Where that's been posted, that's got a performance problem that will impact the load time as well.
Yeah, for sure. So, for example, when there's, let's think of again, maybe an intranet example is more is easier. So if you're looking at an intranet like a portal, right, an organizational portal, maybe it becomes slow every day around 1 p.m. Maybe that's the case. Maybe every day it starts to become slow. Now, it becomes slow because there's a flow of requests, right? And the web server is to blame. Sometimes, but the good news is, from our perspective, is that if you look at the actual results inside that organization, you will probably notice that around 1 p.m. every day, everybody starts getting slower load times. So time of day is definitely a factor. It reflects many things, like, for example, the load on the server. Yeah. So yes.
Can you see which site they open, or?
For Internet Explorer, we can. We didn't look into this here,
Okay.
right? Not in this dataset, but we're starting to get data about that as well.
Because
So,
then you can see if it's intranet related or
yeah,
some Google default
URL.
definitely. So, but for sure, URL is a major factor. But one thing I can say for sure, and again, this comes from maybe personalizing and customizing your own desktop, right? So when you open a browser, what would you rather open? About column blank that just opens the page like that, or would you load I don't know, CNN.com or another crappy news site with tons of videos around the new testing, right? Or MSN. that was the yeah.
Can you split the results between those who use the proxy and those who doesn't?
Use proxy or not? Good question. No data about that. But it's definitely interesting thing to look at.
Good question.
So this is Explorer. I moved to Chrome to be right after it. So this is Chrome. Okay, and this is where the pictures become a little bit useful, because you see it's a little bit different. Now it's different in some ways. First of all, the average load time for Chrome, you can see here, is much higher, right? So it's 8 seconds versus 5 seconds. Does that mean that Chrome is slower than Internet Explorer? No, that's not what I mean to say here. If you want to have a research on which browser is faster, it's better to take a lab, have the same exact hardware, and let them fight it out, right? That's how you do benchmarking between applications. Or another question, like against versions, right? If you want to compare one version of IE with another version of IE, the best way to do it, put them in the lab, make everything sterile, really, really be very precise on how your machines are independent and the same hardware, and let them fight it out. That's the way to check it. This is real world. In the real world, what we're seeing, Chrome loads slower. Okay. Now, it's due to different factors. Okay. Mainly, there's a little bit of an effect of small samples here. So there's much more instances of Explorer than Chrome. So that already changes the statistics a little bit. But what we see here is that when you're using Chrome, first of all, the fact that so many organizations use Chrome in virtual desktops is already a little bit interesting, right? It's being used quite extensively, and there's a lot of room for improvement. The fact that in some organizations the load time is less than 1 second, pretty impressive, right?
Are these installed applications or app feed? Because Chrome is often app feed.
Cool.
Or more often.
Doesn't matter to us.
Yeah,
Still a
but
process.
Then it's the load time is bigger than.
Why?
Don't know.
Subsystem.
You have to pre-install them if you don't install them.
So yeah, but once the application, so you're saying that maybe in any application that's layered, right? So once you double click, there's a preparation phase before the actual process gets started. Fair enough, yeah, true. But to us, again, let's just ignore that phase, because maybe from the user's perspective there is a penalty of a second or two or whatever it takes to do that. But from the second the process actually started, because that's when we start monitoring, right? Until the end of the loading, as we defined it, the results are still need to be similar. So in that sense, yeah, there's probably an additional delay involved with you dealing with layered application, but it doesn't interfere here. Okay, so you can see in some organizations that the average is longer than, it could be longer than 14 seconds. Right, so that's probably very horrible. And in this case, the size of the bubbles, it means that this is a pretty big organization. So thousands of launches per day, average over 14 seconds, bad user experience. Many things to do about it, probably. So again, like Internet Explorer, add-ons, cookies, cache, homepage, look at all those things. There's also a page called Chrome Flags, which has all sorts of advanced the settings that you can play with, and there's tons of recommendations in the internet about things that you can tweak to make Chrome behave differently. It's like in Firefox they have about config and stuff like that. So there's the flags page. You can tweak a lot of settings there to make it work differently. Hardware acceleration, all sorts of stuff. So this is about Chrome.
Can you
This
measure on these flags?
Sorry?
Can you measure on these flags so you can see the best settings?
So we don't know those settings. Just like with the proxy, we don't correlate this with the settings that the users have, but it would definitely be interesting to get this. So 4.7 seconds is the load time for Excel. Okay, now I don't know how many of you work with Excel. I work with Excel pretty extensively, so I have a few tips of my own to contribute to you if you want to speed up Excel. But the main idea, okay, the main thing I have to say about Excel is take a look at the use case. What are the users actually doing with Excel? Because many times people, like, I don't know, in the financial industry, they might open Excel dozens or hundreds of times a day, right? And you have to see what are they actually doing. If they're going to a spreadsheet looking up one number and closing it, okay, you have to stop for a second and ask, wait. You just loaded a spreadsheet which is 15 megabytes on disk, and it has 200,000 rows and 7 workbooks inside, 7 sheets inside, and you're just looking for one number. Do you really need all of that information for that? And it happens more often than you would think. There's raw data in Excel spreadsheets, and many times users don't need the raw data, they just need the statistics. And there's a lot of things inside Excel, like leaving formulas, right? You're opening Excel and starts recalculating everything. Disabling automatic calculation in Excel speeds things up dramatically. And you don't always need, or most of the times you don't need your Excel sheets calculated every time. Mostly you open it, it's already calculated, everything is fine. If you don't need formulas inside the page, just preserve the values. Just do paste as value and save it there. Many times Excel is sort of misrepresented, right? You need it as a storage, and they're using it as a computing platform. So spreadsheet, Excel is a really powerful tool, but sometimes it's just an overkill for what the user needs, right? So reducing whatever Excel is doing for the user is sometimes reducing, you can reduce the speed, okay, dramatically, without reducing functionality, because the users only need the bottom line. So this is around Excel. And again, the article we're going to publish is going to have all the details on how to speed it up specifically. But those are the main things that I would recommend. Word is pretty common, really common in the database. You can see that the load time is pretty high, right? So almost 7 seconds, and it's pretty common. So let's think of the use cases when people open Word, right? So they may open like forms, or they need to fill in documents or patient records on stuff that arrives by email. So the idea is that many times, and again, we all open Word documents every once in a while, right? So sometimes we open a document just to see what's there and to close it. We don't even edit it, right? So the question is, do we need all the functionality of the word processor if we just want to look at some letters, right? So in this case, And I actually checked this with Procmon. I looked with Procmon at a lot of Word launches to try to see what's actually taking so long. In many of the cases, it's the fonts, right? It makes sense because it's a huge directory. There's a lot of small files there. It takes a long time to enumerate and bring everything to memory. So it's the fonts many of the times, but also things like loading the pictures, checking spelling and grammar automatically. It can slow down stuff horribly, right? You're opening a huge document. There is an option called Pagination. It sometimes Word, especially when you open huge files, it starts to divide it into pages, right? From new, and you can disable this. It doesn't have to do it, right? And it slows things down dramatically. And there's tons of printing options. There's like a jungle of printing options in Word which you can play with to make it load faster. And again, the use case is king. Look at what users actually need. Because sometimes all they need is to open it in draft mode and just look at it. And if they open it in draft mode, it will be much faster to open, right? So this is Word. And this is Outlook. Very bad. Okay, so Outlook is very bad, and we all know it. Like if you still use Outlook, right? So you probably know that it's not a fast application to start, because people tend to save huge amounts of data in their data files, right? And it takes a long time to load. But the picture here is really not encouraging. If your average is 10 seconds, that means that almost everybody opens Outlook to start the day. Right? To open Outlook, that's when you start working. That's when you see when your new emails come in, and that's the start of the working process. So many times, the size of PST, auto archiving, disabling RSS feeds, all of those things can speed things up. But notice the fact that the fastest organizations in the sample here, there's one champion there with an average of 3 seconds. Maybe they don't do. Maybe do a very, very slim data file, right? Or I don't know what they're doing exactly. I'm planning to actually check this out and ask.
Unconfigured.
Sorry?
Unconfigured.
Unconfigured, no data file at all. Yeah, or using IMAP, maybe. But in the end of the day, if in their scenario the users get their email with under 3 seconds, I think it's a very good result, especially if you compare here. The takeaway here is that if you have an Outlook load time of 10 seconds, that's your average in your organization, and you want to get it to be 3 seconds, you're going to have to work hard, because almost no organization, at least in our sample, in our customers, have really, really fast results. So the realistic goal for improvement is somewhere between 5 and 10 seconds, and not much faster than that, right? So this is another goal. We sort of want to tell you what is realistic. If you want to make your Outlook faster, you probably won't get it to load in 2 seconds, but 5 or 6 is definitely possible. And this is PowerPoint, not very common in the organizations as, thank you. So this is, again, there's one anomaly. There's some organization that really likes PowerPoint. You see that blue, I don't know what they're doing with it. I'm planning to ask as well. But it's fairly fast, right?
The marketing department of Citrix.
Probably. So the average is about 5 seconds, but most of them have really small samples, and deviations are pretty large, which makes sense because some presentations can be really, really large. And by the way, who here uses the Google Suite for Google Apps? Just me, eh? So I use Google Apps for word processing. No, just us. I mean, so I use it for word processing, and this presentation is also on Google Apps, right? So I can't tell you that it's faster than local Office, right? So PowerPoint is definitely faster, and sometimes when I'm using Google Apps, I enjoy the online features like collaboration and stuff like that, but in terms of user experience, I can't say that it's better, right? It's sometimes more affecting the browser, right? The browser is working really hard, and user experience-wise, I don't feel like I'm getting a better user experience from that. The features are nice with the online collaboration especially. So this is the results for part. Things.
Do you have all
Sure.
these licenses or not?
Sorry? Yeah, we do. We do have partners.
Huh?
Yeah, we do. We do have both. So things that affect all applications. So besides the things that only affect Excel or Word or PowerPoint that we talk, there are things like hardware. Okay, of course, CPU, RAM, I/O network, GPU has an interesting effect in some places. Okay, you'll see where GPU-enabled workloads stuff starts to work better, even for applications that you would not normally expect it to work better. Time of day, like we said, what sort of application are we opening? Is it a document? Where is it stored? All of those questions are relevant, and all of those questions is something that I encourage you to ask if you're researching user experience in a given scenario. So those are like the common factors of what should be looked at. And here's the strategy that we propose in general, how to approach this. So what should we do? If you have a customer or if you have a opportunity where you think you want to research user experience. Here's from our experience some tips on how to get started, right? So very simple steps, right? First of all, just ask your users. Ask the users what is slow, how is your user experience, do things open fast? Just look at them. Look at them starting their day. Okay, ask to stand on the side and look how long people take to open their applications or get their desktops. You will gain like the major idea about how things behaving. So that's the first step. Then try to define what means slow. Sometimes people will tell you, oh, that's not slow, that's okay. Maybe you should ask a few people and try to define what's really slow, but in terms of take into account that anything over 10 seconds, you start, and this is cognitive studies, right? So science says that more than 10 seconds, some of our cognitive processes start wandering and we start thinking about other stuff. So as a rule of thumb, maybe there's a 4-second rule and an 8-second rule, but I'm finding like 8 to 10 seconds. This is where you need to start worrying about user experience. So define slow. Dive in the results, like look at the actual numbers, right? Whatever application you use to monitor it. Control Up is a really simple one, I guess, but there are very much more involved solutions to monitor user experience. I think Control Up is a fairly simple way to do it. Focus on the extremes. That's fun for system experts. If you look at the extreme results, if you see that someone takes, I don't know, 7 minutes to load an application on average, look at that, you're going to discover something interesting, I guarantee you, right? There's always something horrible looming under there. There's either like a 4 gigabyte Outlook data file being copied over from a remote office every time they launch an app and then back. You discover very interesting stuff. So look at the extreme results, and once you're done with the extreme results, you saved a lot of time and you saved a lot of waste in the infrastructure, and then you're ready to talk about the majority. So start to think about how you can affect the user experience of the majority of your users. So 80% of them open a intranet portal homepage, and it has a lot of graphics and active content and stuff that is slow to load. Think of how to improve that, and you win for 80% of your users. So that's like the framework for what we think is a better way to approach user experience monitoring. Questions so far? Yes?
Which Office versions are you using for the jobs?
It's a great question, and we have a mix of all Office versions that are in use. So everything is here. You wouldn't expect people still using Office 2003, but it's still here.
Comparing Office 2010 and 2016.
We're mixing all of them together here. And this is for the purpose that I try to look at Office, like all the applications of the same kind. I don't try to compare one version to another because they're not doing the same things, right? Again, if you want to compare one version to another, make a sterile lab, make them load the exact same document on the exact same hardware, and that will give you the answer. I do have results for what the different versions look like. It appears that the newer the version of Office, the slower it gets. But I'm not. This is not a claim that I would like to make because it's not statistically justified. It's just because they're doing different things, right? But we have to say that probably for our day-to-day experience, newer software tends to be slower, right? That's my experience. Because it usually runs on old hardware. Yes, Gunnar.
Do you want other processes like Windows Update or something like that that could influence?
So correlating this with other activity that's going on the machine at the same time, that
really slow things.
one of the next things that we want to do with this. There's tons of possibilities, and again, I'm sure that you guys, our time here is up, but I'm sure you guys have a lot of ideas on what we can do with this further. And please, if you have any ideas on a specific application we should look into, or a specific technique for improving application load time, or if you have any idea of a factor that can contribute to load time that we didn't think about here, or any other question regarding like all of the tons of data that we have in the cloud, please tweet it, okay? You can contact me directly, and we'll at some point we'll get to analyzing it. And so far this has been a very, very interesting ride. So people are suggesting very interesting things, and eventually it may take us some time, but eventually we come up with stuff that is hopefully interesting. So thanks a lot.